This video follows on from the first video about the 3D viewer and shows some tips and tricks to ensure you get the most from the 3D viewer. The video will cover loading of the 3D viewer, navigating quickly and easily in the 3D viewer, and finally views and switching views. Loading of the 3D viewer. You may notice when first opening a job and entering any app with a 3D viewer, it might take a few seconds to load. This is because the 3D viewer needs to first load its information from the database into its so-called scene graph. Once loaded, however, the 3D viewer can then be re-accessed very quickly in any application. The initial 3D viewer loading time is proportional to the size of the job, with loading progress indicated by the graphic. During this initial loading, it is possible to press Escape to cancel the loading, meaning although the 3D viewer may appear empty, the user can continue to work with the job or view the data in data management, for example. There is a limit to the amount of data that can be loaded in the 3D viewer. In the case that a very large scan job or CAD file is loaded, a message may appear to tell us that part of the data cannot be loaded. What large actually means will be explained later. Different data types are prioritized, so it might happen that scan points or CAD data is stopped being loaded, whilst the points and lines do get loaded. The user is still able to work and will only see the loaded data in the 3D viewer. There are two main differences between Captivate running on the CS20 and Instruments platform compared to the CS35 platform in terms of loading data. The first is that the CS35 has a larger memory and is able to load more data generally, so more points and lines or larger attached CAD data. The second is the loading of multi-station scan data. On the CS35, all scan points are loaded, whereas on a CS20 or Instrument, a maximum of 100,000 points per scan is loaded. When attaching large CAD files, it can happen that the loading limit is reached. For example, it is likely a 100 megabyte DXF file will not be able to be loaded and viewed in the 3D viewer, especially on the CS20 and Instruments. There is no exact limit to the maximum loadable size of a CAD file. It depends on how the data is organized and what elements it contains. The loadable limit is usually between 30 and 50 megabytes. If it is wanted to attach a larger CAD file, it must be reduced in size, either by removing not needed data or layers, or reducing the area that it covers. Navigating in the 3D viewer. Navigating means the ability to control the view of the 3D viewer using tools such as zooming, panning, and rotating. Navigating in the 3D viewer has been designed to be as simple and natural as possible. However, it helps to understand a little bit of how it works and be aware of a few tricks to really become a 3D viewer expert. In the How to Use the 3D Viewer within Leica Captivate video, the basics of each navigation were explained. I will not repeat these here. Let's start with the panning tool. Remember, this is active when no other navigation tools are. In 2D, the pan tool simply moves the map by the same amount that is applied to the screen. If you tap the pen down at a point and move around the screen, the point within the map should always follow the pen. As the 3D view is a perspective view, an extra dimension is introduced. So when panning the data in 3D, it appears to be moving at different speeds because of its depth. What happens when you tap down and start to pan is that the 3D viewer recognizes where you tap and moves the data underneath the tap at the same speed. It's like the pen has grabbed the data underneath. See here as I pan on different areas of the view. When there is no data, a 3D viewer applies an estimated movement. So the trick to successful panning is using the data that you see to navigate in the most comfortable way. Now let's look at zooming using the Zoom Real-Time tool. In 2D mode, this tool always zooms to the center of the view, the amount depending on the pen movement. When we switch to 3D mode, the zoom is also to the center of the view. However, a zoom focus point is calculated based on the data at the center of the view. You can actually see this displayed as a helper symbol. The amount of zoom applied depends on how far away the focus point is. In some situations, the zoom focus point may lock on to some data in the foreground, and you might be unable to zoom further, seen here because of some scan points. In this case, simply pan slightly, and then continue zooming. A new zoom focus point will be created further away. One useful trick is to make use of the Center to Selected Object tool. Simply select a point, press the tool, which places the selected point in the center of the view, and then use the tool to directly zoom to that point. You can very quickly zoom to anywhere you want using this technique, and it works just as nicely in the 3D view as well. Next, we will look at the Rotate tool. This is only available in a 3D view and shares some features with the Zoom Real-Time tool. The rotation applied is around the center of the view, and a rotation focus point is calculated based on the data at the center of the view. This helps keep control of the rotation, as you will always see the effects that using the tool has. If there is no data near the center of the view for a focus point to be created, then the rotation point will temporarily become the theoretical camera position until a new rotation point is found. The rotation focus point is seen as a helper symbol. If you want to rotate around a specific point, simply select it, then use the Center to Selected Object tool to first center the view on that point, and then rotate around that point. The Center to Selected Object tool is a very useful tool to center the 3D viewer on a specific object. For example, in data management, select a point in the list, then in the 3D viewer, use the Center to Selected Object tool to bring that point to the center of the view. The tool also works with lines. Select a line in the list, go to the 3D viewer, and use the Center to Selected Object tool so that the selected line fills the view. In stake applications, use the tool to center the 3D viewer to the objects being staked. Finally, let's look at the Center to Target tool. This is available whenever it is possible to measure a point, for example in the Measure app. The tool works by keeping the currently measured prism or antenna in the center of the 3D viewer, so that the user can always see the data that is around them. This is particularly useful when measuring and coding, for example, where the user always sees the result of their measured points and line work. Even in 3D view, it is like the 3D viewer is following the user around and makes for a great coding experience. Occasionally, the 3D viewer may not work as you might expect. Perhaps you press Zoom Extents, and then everything seemed to disappear from the view. This is normally caused when there is data within the 3D viewer that is very far away from the data you are interested in. First, check there is no design job enabled by accident which you didn't want to see in the 3D viewer. Go to the Home screen and tap here to choose Design Data. Check there is no unwanted design data enabled in any of the pages. secondly, check in the working job that there is no unwanted distant data. Let's refer to it as an outlying point. Perhaps a point unknowingly appeared with very different coordinates, which causes the extent of the dataset to become large. This might happen if a point is missing its height, or perhaps an old total station setup was unexpectedly copied into the job, or perhaps a GNSS reference station was imported. If there are outlying points, this can also have an effect when switching from 2D to 3D mode, and seem like everything has disappeared. This can also be caused by outlying CAD data, or CAD data that has been attached but contains no heights. In the 3D viewer, any data that does not have a height, known as 2D data, will be assigned a height of 0, and in 3D mode will still be visible. Finally, the coordinate system of the working job is always the active coordinate system. When using a design data job that contains GNSS data, the coordinate system must be the same as the working job. Otherwise, the data may not appear in the correct place. Views and switching views. Let's have a look what happens when switching between views. When switching from a 2D to a 3D view, the view is transformed based on what's visible within the view, and initially should look like it is more or less in the same position. If the view is not switching as expected, there may be an outlying point as previously explained. When switching from a 3D view back to a 2D view, the last 2D view is always restored. This is a useful feature if you become disorientated in the 3D mode and perhaps cannot find your data anymore. Simply switch back to a 2D mode and the last 2D view will be visible, right where you left it. Actually, the view type and position is always stored with the job. This means that when accessing any 3D viewer in the same job, whether in a different application or even the next day, exactly the same view will be reloaded. That concludes the video. Thanks for watching.